This is the AP Stats Chapter 1 Lesson 3 homework video. Now, I've mixed in a lot of the ideas together from the beginning just because everything is really one. We're all looking at how to describe a distribution. So some of the things that we focus on in 1.3 I've definitely already mentioned and even calculated beforehand. However, now there's an extra focus on them and you can be sure that they'll appear on the quiz and then the test. And you also know that they will be quite key in interpreting data for your project and any other time you're looking at real data. So let's look at measures of center. When we say center, we're really talking about what's a typical value. What would we expect? Many of you have had teachers that use the mean as what to expect, what the typical student got on a test, because it's the average. I always encourage other teachers to use the median because it accounts for any potential outliers and gives you a better idea of what that middle student did. And really, if you wanted to really get a sense, what is use the IQR, the middle 50% of your students did. So the mean, add up all your observations, divide by the number of observations. That means if I have 11 students in a class, I add all their scores up and I divide by 11. We represent that with X bar. That's very key that you take note of that. Anything with a little symbol above it, like X bar here, is from a sample. So we'll have more symbols we introduce throughout the year. Mu here, which looks like a U, is the population mean. So oftentimes we use a sample mean to estimate the population mean. For example, the average number of hours an American sleeps a night. We can't ask everybody and average it out, so we take the sample and find that. With uniform, symmetrical, and roughly symmetrical distributions, the mean is awesome. We'll use it and see how much detail we can find out about how plausible certain outcomes are given a certain mean and standard deviation. If you picture it as the point on which the curve would balance if placed on a triangle. So the median would be the middle number if we ordered the numbers from least to greatest, smallest to biggest, which is what's described here. If we have an odd number of values, meaning if we're collecting data about the number of classes you've taken at Sacred Heart, and we have 15 values for the students we know the eighth is the median because there are 7 numbers smaller and bigger. However, if we had 16 values, then we have the 8th and the 9th being the middle values. So if that's the case, we would picture the median actually being between those two values. So what we do is add them up and divide by 2. In other words, we take the average of those. We use as a measure of center whenever there's skewness in the graph because the median won't be swayed by those large values or small values that are far out of the pattern of the graph. And we should really picture the median as the equal areas point. So an equal amount of area would be on the left and the right of it. If we looked at the curve on the left and the right, there'd be an equal amount of area. If it's dot plot, same number of dots on the left and the right when we look at it that way. So if we looked at that in our graphs, here we have the mean, the balance point. Remember, if you're on a seesaw with your little brother, little sister, they have to sit way further from the middle to balance you out. So that's like values being outliers, increasing the mean. So when we say skewed, we're saying it raises the mean either right or left. We'll also see positive skew or negative skew. Positive skew is like skewed right, negative skew is skewed left. We're going to stick with right and left for ours, but here's some examples to get the idea of where the mean, median, and mode lie, depending on your values. The median here chops this curve into 2 equal areas. So this is a nice visual to go back to. So I'd pause this now, go ahead and review it. The mean being the balance point and what that means, the median being the equal areas point. If our distribution is roughly symmetric, well, if it's perfectly symmetric, our mean equals our median as you see here. So some students say, then why would we ever use the mean? Well, for some basic things looking at data, we really wouldn't just use the median. However, when we look at more complicated calculations, where we look at the probability of an outcome occurring, given a normal curve, an isometric, a normal curve is this bell shape, then we can calculate probabilities and determine if our results are consistent with something or disprove them. So we're going to get on to why we'd use the mean and standard deviation, which we use quite often. But right now, just know most of the time the median gives us the best picture for just doing simple description of where the data lies, not comparing it to anything. The more the skew, the further the mean is, either to the right, skewed right, which is positive skew here, or skewed left. So a quick example, in 2009, the minimum salary for MLB, the Major League Baseball, was 400 grand. That means most players earn close to the league minimum. If you come up and if you're a rookie, you're at league minimum. Superstars earn far more than the minimum. That already lets us know that we're looking at something that's probably skewed right, with very few outliers far to the right for the people that hit a lot of home runs, for the people that signed big contracts. And that means we had a mean of over 3.24 million, but a median of 1.15 million. This is an excellent example of how skewed, or how the mean does not provide you with an objective idea of what the typical player makes. This number is influenced by really big contracts for superstars. So the median gives us a better example of what a typical Major League Baseball player earned in 2009. So here is your multiple choice based on mean and median. So go ahead and pause this in just a second and decide which of these represents the best answer based on what you just saw, after reviewing mean and median a little bit in 1.3 of your book. What do they mean? What does it mean to be skewed left or skewed right? Pause now, and then we'll go on with the rest and the FRQ. The interquartile range, I've described it as the way to measure spread, especially if there's skewness. And it's pretty essential when there's skewness. So an IQR breaks up our data into quarters. So a median, we've already broken it in half. So just picture it as looking at the two sets of data, the smaller half, and chopping that in half. Now you've got quarters. The larger half of your data, chopping that in half. We have quarters on the bigger half. Basically, we find the median, look to the left, find the median of the first data set, and then look to the right of the original median and find the median there. Now, why would we want to do that? Well, most of our data is the middle 50%. So what this lets us do, and with our box plot, is kind of focus on where the middle 50% of the data is. Keep in mind that the middle of our data, there's no outlier. So we're seeing where typical values lie. Just like we said, the median is the typical value. The IQR gives us an idea of the range of the typical values. So how much bigger and smaller than the median are they? It gives us an idea of how spread out most of the data is, or at least half the data is, without worrying about maybe there's 2 or 3 values that are much higher. Like if it was a test score, maybe there's 2 or 3 students that scored far higher than the rest of the class. Maybe if it's temperatures in the US, maybe there's Wisconsin and Minnesota where it was super cold a couple times, and those would skew the median, and they would skew how spread out the range and things like that. So we use IQR to say, well, what's my middle 50%? How spread out is that? So how do we calculate it? So we divide the data in half. Q2 is the median, 2 quarters, 50 cents, 50%. Q1 would be the median of our first half of our data. Q3 the median of our second half of our data. Our interquartile range, once we find Q3 and Q1, is Q3 minus Q1. So we would take the third quartile and the first quartile, and that's how spread out our middle 50% of our data is. We define outliers with this strict quantitative way. Many of you asked me in class, how can I say for sure if this is an outlier? And I just wanted you to look at the pattern. I still want you to look at the pattern, but now we can quantify them. So we base an outlier on the middle 50% of the data. So we see what our IQR is, which is right here in parentheses, and we multiply that by 1.5. Now think, why do we multiply that by 1.5? Well, we want to see if, given that, 1.5 times that above Q3 represents an equal spread of the data beyond that. So basically, we're saying, what's the IQR if things are 1.5 times that over Q3 or 1.5 times that under Q1, they're an outlier. So I would find Q3 minus Q1, multiply by 1.5, add that to my third quartile. If the value is greater than that, then it's an outlier. Q1, I do the same thing. Q1 minus 1.5 times the IQR. If the value is less than that, it's an outlier. Now, an awesome visual way to sum this all up is a 5-number summary. Our 5-number summary gives us the minimum, the first quartile, the median, the third quartile, and the maximum. So 25% of my data is here, 25% is here, 25% of my data is here, and 25% of my data is here. So you can see I have a lot of values clustered in this area, just looking at this. That's why the box plot is a very nice visualization. Now one thing about the box plot, if we have an outlier, we won't include it here. It'll be an asterisk. So that's what I just noted there. So our 5-number summary would be our smallest value, Q1, our median, Q3, and our maximum. We use it to make a box plot. So your central box is, this is my middle 50% of my data. So from here to here. The vertical line marks the median. We call these whiskers. Now, we've done this in class and shown how to show outliers too. So it's really important to always choose that box plot on your calculator that shows outliers. And then you can trace the whole thing. You can also go to stat calc 1var stats for your list and get the 5-number summary when you scroll down. And before going on, this is a good place to mention that all those calculator functions for the entire year are in one document on Schoology for you under, I believe it's course resources, the folder. Standard deviation. So an alternative to IQR is standard deviation. It's based on the mean, whereas the IQR was based on the median. So it's the average distance of all the observations from their mean. So we'd find all the distances, and we don't care about whether they're bigger or they're smaller. We just want to know how far they are. So we square them, and we add them all up. We divide them by the number of values minus 1 and square root it. Before we square root it, we'd call it the variance, which is also important, and we'll get to. After taking the square root, it's the standard deviation. That formula looks like this. Don't be overwhelmed by it. This is just saying this summation symbol, the big E, is saying add up all the values minus the average. So this is each value, each individual xi represents individual, minus the mean, square them because we don't care about bigger or smaller, and then add them all up, then divide them by n minus 1. Once we square root that, we get our standard deviation. Median and IQR usually give a better interpretation than mean and standard deviation for a skewed distribution or anything with outliers, especially strong outliers. But mean and standard deviation are going to be incredibly important moving forward, so you also need to know how to calculate them. We'll be using them a lot. In fact, even more so than the IQR and median. All right, here's a good point before you answer this FRQ to go through the 1.3 review in your book, to look through examples. Here, related to our book, Food Rules for the Year, are the data for the amount of protein for various foods in one student's food log, with 19 items for 2 days of food. Make sure you get all these values. You can use your calculator. Remember, go to Stat, Edit, and enter all these values into L1. You should end up with 19, so you should see on your list it'd be L of 19. Or when you do the one variable stats, you should get n equals 19, the number of values. I'd like you to find the 5-number summary and describe the distribution. So that means you need to do two things. Find the 5-number summary and then get a good idea of the graph. Calculator, I would use the histogram and the box plot to get a sense for the shape and center. And then go ahead and answer the free response question. So look over vocab, look over the outline posted, look over the summary for section 1.3. You might want to just whiz through all of chapter 1 to make sure you have a good sense of this. More than anything, if you're writing this down or using the calculator, make sure you don't miss a value. So just double check that you get all 19 values. Go through and chop them off one by one so that you don't miss something, and then answer your free response question.